Now let's sketch the graph of cotangent of t by making a table. We'll go through this much faster. So when we graphed tangent of t, we looked at this unit circle and we said, well, tangent of t is not defined at the top and bottom because when you compute tangent of t, you divide by x. Here, we're dividing by y. And if you divide by a y value of 0, then the cotangent of t will not be defined, much like the tangent of t is not defined at these upper and lower points where the x-coordinate is 0. So we need to make sure, or perhaps better said, I'll make the observation that cotangent of t is not defined when x is 0, and x is 0 not at the top and bottom of the unit circle, but on the left and right side. Also, much like the graph of tangent of t, cotangent of t has period pi. And so when I make my table, I'm going to want to create a list of t values on some interval of length pi between the two places where cotangent is not defined. And the common place to do this is the t values between 0 and pi. So when I make my table, t, cotan t, my first t value is going to be 0, and this is where cotangent is undefined. Much like tangent, we'll see that there is an asymptote there. Then at pi over 4, cotangent of t is 1. You can verify this if you'd like. It's just you take the x-coordinate and divide by the y-coordinate, and you get 1. Then at pi over 2, cotangent of t is 0. At 3 pi over 4, cotangent of t is negative 1. And finally, at pi, it's undefined again. And so I'll begin sketching over here on the right. According to my table, make myself some axes, t and y. Let's call this pi over 4, so that this would be pi over 2. And I'm filling out pi over 4, pi over 2, and I'm going this way because look at the t values that I need. So I need pi over 4, pi over 2, 3 pi over 4, which is right here, and finally pi, which is here. I'll need a y scaling, so I need +1, 0, and -1. So let's make this positive 1. That would make this -1. And I'll go ahead and draw in my asymptotes where this function is not defined. It's hidden by the y-axis, this leftmost asymptote, but it's there. Now let's go ahead and fill in these points that I know, pi over 4 and 1. So pi over 4, comma 1. Pi over 2, 0. And 3 pi over 4, negative 1. And if you want to see some more details, you can refer to the book, but the curve will look much like the cotan curve, much like the tangent curve, except instead of sloping upwards, it slopes downwards. And at the asymptotes, we can ask ourselves what happens by taking a look at the unit circle. So if you have a t value that's pretty close to 0, then at this terminal point, the x value is almost 0, so approximately 0, and the y value, the x value is not approximately 0, the x value is approximately 1, and the y value is approximately 0. And if you do x divided by y, and this one is approximately 1, and this is approximately 0, but positive, important to note that it's positive, the y value is positive because we're in quadrant 1, then this will be a very, very large number. However, if you're very close to pi, then x again is approximately not 1, but -1, and y is approximately 0, but note that, again, it's positive, so it's almost 0, but bigger than 0, and when you do something like -1 divided by a positive number really close to 0, you get a really negative number. So think something like -0.999 divided by 0.001. That is a very negative number. It would be -999. This is something that I probably should have mentioned back when we talked about tangent. Because when we talked about tangent, we talked about taking a t-value that was really close to pi over 2 in quadrant 1. And I said, well, you're doing y divided by x because it was tangent. Y was really, really close to 1. X was really, really close to 0. But it would be important to mention that x is bigger than 0 here. Because if x is bigger than 0, then that makes this ratio positive, and that's why as you get really close to pi over 2, tangent gets really close to infinity. Or another way to say that, as t gets really close to pi over 2, tangent gets really, really large and positive. But in any case, for the cotan function here, we have as the t values get really close to 0, the graph for cotangent gets really, really positive. And as the t values get really, really close to pi, the y values get very negative. And so this would be the sketch of one period of cotangent of t. And cotangent of t has many of the same characteristics that tan does. The graph looks incredibly similar, right? But of course there are some differences. So cotangent of t, it has range, all real numbers, because if for every horizontal line you draw, you get an intersection, just like for the tangent function. Every horizontal line has an intersection. However, there are places there are t values for which cotangent is not defined. And so the domain is not all real numbers. The domain, so cotangent has domain equal to all t except when you are at the left or right hand side of the unit circle. So t equals 0. That's a t value which is not defined. T equals pi, but also t equals 2 pi, because 2 pi, if you go around by 2 pi, you end up at the right half of the unit circle. Also, cotangent of t is not defined for 3 pi, because 3 pi you end up again on the left side. In fact, if you thought about this for a little while, you would come to the realization that this is defined for all t except t values of the form an integer times pi. So 0 pi, 1 pi, 2 pi, -pi, -500 pi, those are all not in the domain of cotangent of t. The period is pi, as I've mentioned before. And I'll briefly mention that it's a one-to-one function, so it has an inverse. Finally, just a remark on the differences between tangent of t and cotangent of t. Tangent of t slopes upward like this. Cotangent of t slopes downward. And the asymptotes of tangent of t have 0 at the center. So they were these here, minus pi over 2 and pi over 2, whereas the asymptotes for cotangent of t are at 0 and pi. So just a remark on some of the differences.